That's more.
Thank you very much all for your interesting talk, and it's not because it was historical that I don't like it, of course. It was a very nice history of science. I'd like to, but it's very interesting, I think, also because it links to some point that was made yesterday by Emiliano, is that there is a difference, if you talk about what triggers scientific revolutions or what triggers shocks in general, what is, for example, financial shocks also, usually there is talk of endogenous and exogenous causes. And I think if you talk about tech first, tech last, this is, you have actually given an example of an exogenous shock and of an endogenous shock. So the tech first, so the discovery of the new gases, or the technology that makes available new, or that triggers a scientific revolution, or this is an exogenous event. It's something from outside, like you literally mentioned. It is something from outside science that happens, some technological advance that has such an impact on science that it changes, of course. And on the other hand, the tech last example is then it is triggered by something inside science. It is, like you say, the gradual feeling of unsatisfactoriness of the dominant paradigm that leads to exploring new kind of avenues. So this is a factor that comes from inside science, and so both. Yeah, I would. I see the difference between both the first tech and tech first and tech last cases, and I think they are the two. They are indeed. You have given cases of it, about two paradigmatic cases, I would say, of exemplary cases of both kind of corrections. But then I would ask you, why do you think in the endogenous case or the tech last case, then the last case that you mentioned, why do you think, or do you think there's a general way of deciding when a paradigm has become unsatisfactory? Do you think there could be any kind of guideline for saying now the paradigm has proven unsatisfactory, we should take a new avenue, maybe this will work?
The first part, I don't really agree that the tech last is entirely approaches, because what I'm I wouldn't agree it's entirely endogenous, because I mean, it depends what you include. If you include science, you include all the practical applications of science, then it is endogenous. But it doesn't come really, if you like, from the theories and the experiments. My point is it's an application of science, in this case to surgery, to carrying out surgical operations, which I would see as a practice which is science-based, of course, but is not strictly part of science. It's a problem. So I wouldn't quite agree with the characterization, though I partly agree, because there is a sort of some internal endogenous thing. Can you, not really. I don't see any way of recognizing when it's a good move to start revolutionary science. I mean, you can easily try and start a revolution, and it doesn't succeed. I mean, this applies as much in science as in politics. I still remember back in the 60s, there were all these members of the Workers' Revolutionary Party who were handing out pamphlets at London tube stations to try and encourage a Marxist revolution in Britain, but it didn't work. Though they had some points, there had been the miners' strike and other things which suggested that this might work. Then I think I've mentioned some of you, I had this friend Rupert Sheldrake, who he adopted a revolutionary science approach. For those of you who don't know about Rupert Sheldrake, he was a contemporary of mine, and he started off as a sort of very promising high flyer in orthodox science. He was working in botany, plant science, and his first work all his papers were published in leading journals. He had a research fellowship at Cambridge and so on and so forth. But then he decided that one thing I didn't mention, part of the reason was we need Popper, oddly enough, not Kuhn. Because Popper said you ought to have new, bold ideas in science. So he decided to abandon the standard and invented a new approach using morphic resonances. Now this was back in 1975 or something. So I mean, it didn't. I mean, it might have worked, you know, within 20 years. But it didn't work. So I'm sure there are people who try to start revolutions and actually it doesn't work. So I don't think I would hope to. I'm just looking back and seeing if we can explain. Maybe you could give a few hints. I would be prepared to say there's some heuristics here. It might be useful if you're doing theoretical science to study, say, related technologies. You see, one thing that strikes me very much about Einstein, everyone says, it's amazing, this man started the revolution in theoretical physics when he was working in the patent office. I mean, isn't that incredible? But nobody, I don't think anyone's ever suggested that might have actually been useful. It could, that must have put him in touch with all the technology that was going on at the time, and that could have been stimulated. So this might be a heuristic thing. Or again, just focusing, if you could pick out a really serious practical problem, that, you know, and work on that might be it. So there might be a few heuristic guides, but when it's right to switch, I mean, sometimes it works, sometimes it doesn't. You know?
It's a leap of faith.
Well, it's just trying to see, you know, if it doesn't work. I mean, Lenin tried it and it did work. People have tried revolutions and they just end up in jail, you know. So, you know, it is a bit unpredictable. You don't, luckily in scientific revolutions, you don't actually end up in jail, but you may not get a job or a professorship or fellowship of the Royal Society and so on, which otherwise you would have got. So.
Just to this last point, I think that Jürgen Renn at the Max Planck Institute in Berlin has written about this influence of the technological background in which Einstein was working.
Perhaps afterwards it would give you the paper, I didn't know that.
Yeah, I think that his group, because they've been working on
Yes,
it.
that's very interesting.
But I had a question.
Can you tell me, I've had some thoughts about, what do they suggest might be?
Oh, I'm not an expert in that area. It's just that I was working there. It was impossible not to notice that they were doing some such thing.
Oh, I see. Well, I was working.
And I was working in a different group, so I.
Yes.
Which group is this from?
Jürgen Renn's. Yeah.
Oh, well, if you give me the details, I'll be very interested.
No, I was just having a clarificatory question about your description of Kuhn's view about revolution, because I think that while he had made those statements about revolutions being anticipated by piling up of anomalies and crises in the first edition, I think that in the 1970 edition and in the later publications, I think I got that from Paul Honig-Hühne's book. He revoked that time and said that no, revolutions may come about in various different ways, not only by the piling up of anomalies.
Well, I don't know, I've read a lot of Kuhn.
That's in the
came across
post
that,
actually.
but I'll look that up and see if you. Maybe I ignored that because on the whole, I think my attitude to Kuhn is he wrote this brilliant book and then in his later thought he threw away all the good bits in it. So maybe I did. Maybe that was a bit that he threw away that I didn't agree.
Well, I'm pretty sure that he did that in reaction to some objections that were made. I wonder whether those were the same
along the lines of
cases or not.
But did he put forward? I never came across an alternative theory.
I promise I sent you along with the email also.
Yeah, well,
some passage that I
they're
had.
very helpful. Where's the answer to that? I don't want to get Kuhn wrong.
Okay, I'm a physicist, I'm not philosopher, and my question is, if you consider, for example, high disease superconductivity, I don't know whether you have ever considered this field, but
Unfortunately not.
it's very interesting because you see, there is another element in the game, which is sociology. Because in ITC superconductivity there are something like 50 new papers a day, both in theory and experiments. And as the experiments are really poor constrained, in the sense that controlled. Okay, so with this new material, it's very difficult to understand what is what. That's the problem. So there is a very confused situation, and it is not clear in which how this can be solved. I mean, if you have a good theory how this is superconductivity, you can find many experiments which agree and many experiments which don't. Because the experiments themselves are not clear, in the sense that they are not well controlled. So maybe you have a good theory, but you are comparing them with wrong experiments. So, and as there is such a big number of data and papers, just it's a situation which doesn't have any, it is not clear how this can be solved, unless we will find out a new material which will clearly clarify this. I mean, for example, you find IPC superconductivity at 200 kelvins or more.
Well, this sounds to me that this is a sort of new feature of very recent science,
Yes.
Which doesn't really seem to fit into the traditional models considered by philosophers of science, which admittedly are mainly based on earlier periods, when there weren't that many experiments and researchers. So maybe it looks as if this is perhaps a new phenomenon of recent science, where instead of having you don't have a sort of Kuhnian type situation, it's a single dominant theory. Instead you have lots of different theories, hundreds of experiments, and some support one. So I think, I'm not sure what to say about that. Maybe we need a bit to update philosophy of science a bit, to deal with cases of this sort.
The experiments are not clear in the sense that like the material of Mercury, like there is a clear experimental fact. Here the experimental facts are in contradiction with another one. So you don't know. So for a student who starts to enter in that field, it's just a complete mess.
Well, I think that's a very interesting point. I do think probably philosophy of science needs to be updated, that some of the traditional models, etc., maybe don't apply to certain situations in science. I certainly found I got interested in philosophy of medicine. I certainly think that most of the models are founded in physics, and indeed earlier physics, and they do have to be modified in medicine. So I think that's interesting. Maybe you should take to doing something with space science yourself. Anyway, perhaps it's better to do physics, but it's a good point to raise that.
Do you take a different approach to Kuhnian revolutions as propelled by new discoveries rather than accumulation of anomalies, the bearing on the issues of realism? Do you think that your account of revolutions is less is clashing less with a scientific realist vision of the progress of science? Because it seems like the discovering new phenomena, even the examples you gave, can be accorded more with a causal explanation of the phenomena rather than just anomalies, which sort of by definition are not explained, insofar as they're anomalies.
Well, that's a very interesting point. Possibly so, because I've always favoured philosophically scientific realism. But certainly when I was thinking about this problem, I never thought about scientific realism, but I could have been influenced unconsciously by that. It's possible. I think you may be right. If you focus on anomalies, then you have this idea that theories can't be that realistic because they're always anomalous. Whereas if you think, essentially, I think the ideas that I want to say is not so much negative, it's a bit moving away from positive. It's not that there are difficulties in the old theory, it's just that you've got all these new results and or urgent practical problems which you don't know how to solve. And so you're kind of encouraged to, it's sort of, you get excited by all these new things, and that's what pushes you forward, rather than getting worried by the details of existing theories. But you may be right, yes, I would appreciate that. I'll think if I could develop this.
I just wanted to add a suspect that this, the typical situation of also of many human sciences today is the proliferation of models. Proliferation of models that they are all independent, they do not speak between each other, and this is strange if compared to the tradition, to the traditional image that we have of science. So they spoke about rational disagreement. So there is no rational disagreement. This is typical more than the reproduction of the scientific knowledge. It is typical of the reproduction of philosophical knowledge. You remember the proliferation of metaphysics, modeling, abstract, and
A comment on that in relation to Kuhn, because Kuhn does say, it's just a few paragraphs at the beginning, he does say something about the social sciences. And in fact, he says his views on the natural sciences crystallize when for the first time in his life, he was originally trained as a physicist, and then he went into history of physics, and then he went to this organization, the Center for Behavioral Sciences, I think, at Stanford or Berkeley, Stanford, yeah. And then he said, for the first time, he met social scientists, and he discovered, surprise, surprise, they're not the same as natural scientists. They behave in a different way. And in fact, it was exactly the point that you made there. They seem to always be discussing foundational issues, that they all have different points of view that they're working on, and so on. And so this crystallized in his mind the idea that the key thing about natural science is that they all agree on the paradigm, whereas the social scientists don't. So I think there is a potential of developing Kuhn's ideas to the social sciences, which I don't think he ever did himself, in which you say in the social sciences, instead of having a single paradigm, in every field you have several paradigms, and you have the social scientists are working on their paradigm, and actually to some extent ignore what the others are doing, which is also what happens in philosophy as well. So this would apply to philosophy and social sciences.
yes, but you know philosophy is philosophy. In some cases, you're faced with some bad philosophies. So social sciences, in some cases, you feel unsatisfied. So philosophy is better. It provides more precious knowledge.
See, well, I wouldn't have to
I'm wondering how far your account is really different from, so the idea that discovery is closer to evolution rather than anomalies, because if we consider with Laudon, for instance, that something becomes a problem only once an alternative poses a solution. So an anomaly is not an anomaly unless an alternative theory has a solution for it. Then a discovery of a certain new phenomenon, which can be explained by a new paradigm, immediately becomes an anomaly for an old paradigm. So aren't you actually saying more or less the same? Because, so we have revolutions due to discoveries, which are explainable with a new paradigm, but therefore they are anomalies for an old paradigm, in which case we have again the old thing that revolutions are caused by anomalies being triggered. Or is it rather about accumulation?
Well, no, I wouldn't agree with Gordon, because I don't think you need an alternative for something to become an anomaly. I mean, there are lots of anomalies in Newtonian theory, which everyone recognizes as anomalies, and there was no alternative into general relativity. Or, well, you need to qualify that. So I think you can recognize the anomaly without it, I would say. So I don't agree with Gordon's view that you need an alternative to something to become an anomaly.
On the point of internal dynamics, although Kuhn doesn't say this explicitly, I think, and I'm not defending a general model of evolution here. I think quite different in some important respect. But I think there are some resources in Kuhn for not having to say that you have a multiplication of a whole bunch of anomalies. That just one small anomaly or two can become more and more significant as the field matures. In the early stages of a paradigm, there are lots of gaps. There's lots of wiggle room. But as the gaps get filled, I mean, thinking of physical science, the biological sciences, and chemistry, and so forth, flatter structure. But as the gaps get filled, even small discrepancies gain greater leverage. And if you can't really handle them, they begin to topple now tight connections to related principles or phenomena, whatever it might be, so that even a relatively mild anomaly can become more and more serious without any new discovery, without any change as the paradigm. Does this make sense? As the paradigm moves forward, the gaps get filled and the deductive connections get tighter when the network becomes more consolidated. I think that resource is there in terms of, but even a single problem like, in a different sector of physics, the partition there, that roughly every mode of vibration is going to have an equal share of the energy, leading to what Ehrenfest called the ultraviolet catastrophe. It just became quite clear by the end of the 19th century. Physics just pointed in this direction, and there seemed to be no way out. That there was just no wiggle room left for people to deal with this phenomenon, because it was provable from the canonical formulation that the theory that achieved by then. So in that regard, it doesn't take numerous anomalies. A single one can be decisive. I think the Einstein case is interesting. Again, this is going to be different from lots of other cases, but he apparently was, according to controversial discussion, he was not aware of the Michelson-Morley results, or did not take that into account. But we know from his paper on the electrodynamics of moving bodies, he was very concerned about asymmetries of other kinds that he was focusing on that other people were not. And so this gets, unfortunately, sort of back to our kind of great man conception in this particular case, which I wouldn't want to generalize too far. But it turned out that his approach was very successful in other ways, and that he was very lucky that Planck, liked his approach and promoted it. Otherwise, it might have been ignored for quite some time. But so in a way, he the anomaly came into existence in this particular case, and somewhat the way Dunya said, and the alternative ideas that he was able to develop that dissolve the asymmetries in Newtonian versus electromagnetic theories.
Well, I think you've got a point there that anomalies could become more serious, but I think that is actually different from what Kuhn himself says.
He doesn't explicitly say that. My point was there's the resources in Kuhn to say this.
But he could. But I don't think, your theory would be more persistent anomalies, which get harder and harder to explain. But I don't think that really explains the Einsteinian revolution, because, as I pointed out, there were very few of them. There was only the perihelion and Mercury, which had actually origin. On the other hand, if you look at the new discoveries, you see, the old thing is that most textbooks of relativity always begin with the Michelson-Morley experiment, suggesting that this was what really influenced Einstein. Now, I think he did somewhere claim that he had heard about it. I don't know whether that's true or not, but I don't think that was the main influence. After all, it was 1887. If that had been the key factor, the revolution would have occurred earlier. So we've got to look at things that are happening near at the time. And actually, you do have a whole build-up of discoveries. The most important, of course, is the discovery of the electron, 1896. And then everybody was investigating the properties of electrons. It's just like gases, but there was this. And then they discovered X-rays, then they discovered radioactivity, of course. And then there was the whole booming of development of electronics going on. You know, valves, radio, all these kind of things, all being developed at that time. So I think if you do just before, in the decade before 1905, you really do have an enormous build-up of discoveries.
No, I think
So-
it's true in that case. It really softened up the old theory. And the electroviolet catastrophe thing was more the introduction of quantum ideas, but not relativity. So I agree the Einstein case is
As regards to quantum theory, I would say that Planck's resolution is not yet revolutionary. I mean, it is
I agree, and Kuhn himself argues that.
and it's interesting, you see, if you look at that revolution, Einstein himself thought his paper on that was more revolution. And the key thing that his paper is all about is, of course, the what's it called, the photoelectric effects, which is all to do with, which was being used for all sorts of devices at the time. So that was the thing he focused on. So anyway, you can see the way I'm going to sort of give an alternative explanation of Einstein. But I didn't mention Einstein because I'm not really that. I mean, I know a bit, but not
There's
that.
another answer
Yeah.
from
Yes, just to follow up on the
Yeah.
discussion that has been carried out here, I'm trying to follow Donald here, where you said that it's not the anomalies that trigger the revolution, rather it's the new paradigm that creates the anomalies, you could say, because as long
Hey,
as
that's Lauder's, not
well, yes,
let's say Lauder's view.
but
Yes.
I also read it into what you were saying. Maybe I was wrong there. But it's Kuhn also discusses this already in the structure of scientific revolution. I think not only in the
I
post.
think, sorry, but we have to stop because they are going to close the villa. And although it is a nice place to spend the whole afternoon and open up on Monday morning to the education. So, anyway, yes, we have to. But now, I have to thank everybody, you and the speakers today, but all the others, and especially Emilia.
Yes.
Yes, thank you very much. So we have, yes, we'll be trapped inside.
You see, I know more about it.
That's waiting for the double angles. They
You're staying in
Yeah,
Singapore, right?
they will be there for
We
the
are
next
also
3
staying.
days or
Okay, then we don't.
I leave on Wednesday.
Here you're leaving, right? We see you again. Okay.
When it was reached out, feeds into the parabox non-linearity, internal dynamics, and it's as if the theory that approaches a more and more physical state of the slightest discrepancy now has tremendous impact that it did not have in the earlier days.
That's
The degree of non-linearity increases in time as the
just before the revolution, very small, very exactly. Like you said, it will rule it's a technology.
and especially the violent catastrophe it becomes clearer by that point. There's no alternative. The theory just takes this direction. There's no way out.
Yeah, so.
Every day,
But you were right to make the analogy, for example, but also there you see often descriptions of how a system so Wednesday, for example, I published Stefan Zweig's description of Austria before the war, and how he describes how the people were born, they already had the chance to govern